So what I want to do is to try and bring together some of the technical themes you've been seeing over the last few days, and give them some kind of perspective, and that will hopefully lead up to some small examples that I've written or been involved in within our consulting team. But first of all, I'm going to try and set this really broad scene here of how does our world relate to the LLM world, and why was it that Stephen set out this vision right on day one, and why we were invited to be one of the first plugins to GPT when ChatGPT when it provided plugins. And really, this is the story of statistical AI versus symbolic AI. So I'm going to try and define what I mean by that. The large language models sit firmly in the statistical AI world, that they are using machine learning models based on a lot of data to predict the likely next word in a sentence. So the language models are building a model for human language through lots of experience. So it's been said, and I think it's a really good summary, that they are effectively autocomplete on steroids, that all they are doing is trying to figure out the next word. Now, they are so spectacularly good at that of course the next word that follows a question is often the answer, or the words that follow a statement can be the explanation, or the words that follow a set of instructions can be the correct decision. And so you get this kind of emergent behavior that appears to be intelligent. But it's worth remembering that there is no model of the world in there. There's no model of physics of why things happen. There is only a language model of the words that typically explain things rather than any actual understanding. Now, in contrast, we come from 30 years or so, 35 years now of symbolic AI, which is a completely different fundamental approach. It's defined rules of behavior for structured inputs. So, when we take 2 plus 2 and decide that's 4, that's because 2 and 2 are well understood entities that represent integers, and that there is a defined rules of behavior for adding integers together, and so we know what plus will do, and we can follow that sequence of steps. It's not experiential. It's not that we've read lots of books that happen to say 2 plus 2 equals 4. It's because there are rules of behavior for those objects. And of course, in our world, that's a really, we spend a long time being very broad in the coverage of all of those things. So if you even just look at the world from a data science point of view, that's things like machine learning, where you're doing all of these sort of structured operations like the gradient descent on matrices to fit models. It's classical statistics. It's kind of real world things like entities like cities and locations. It's graphs and networks and flows. It's time series and seasonal adjustment. All of these kinds of data, kinds of things in the real world, different sources of data, whether it's image and video, they all have structure and they all have rules of behavior. And even we've had for a long time various technologies for doing text analysis, but never in a way that that really lives up to what the LLMs are capable of doing. And of course, there are lots of very specialized areas of rules of behavior, such as actually having a model for the way physics or chemistry or biology works, how engineering of materials behave, and how whole systems of those things put together. So when you take those two worlds and sit them side by side, the thing that's kind of interesting and became very clear to us after our momentary existential consideration of this new LLM world threaten what we've been doing, we realize actually that their relative strengths and weaknesses are actually almost completely opposite. And this is the kind of the key realization of why we want to bring the two worlds together, that there are things that computation is naturally good at, following complex rules by definition, things like big data, reliability, that models typically are fairly deterministic. So if you can calculate something once, you can calculate it again the next time the same way. These are all things that the LLMs are actually pretty bad at, that they, even at basic things like doing arithmetic, large language models can't really do arithmetic when it gets at all complicated, because they don't actually understand the rules of arithmetic. So they'll get 2 plus 2 because they've seen it before. But by the time you get to something like 3 to the power 96 or something, chances are it's never seen that calculation. It'll know it's going to have a whole bunch of numbers in it, but it doesn't really know much more than that, and it starts to just become completely inaccurate. And certainly whenever there are sequences of steps where doing one of them wrong wrecks the whole thing, that's a world for code and computation. Excuse me. But they do bring to the table things that we've always struggled with, that computation is not very good at handling wide ranges of inputs. Um, if you're a user of Wolfram Alpha, you'll know that it does a reasonable job of being able to take simple questions and do really interesting computations with those. But as soon as you try and speak to it in a natural way, it gives up. It can't figure out what exactly the essence of the question is. So you have to learn the language of Wolfram Alpha a little bit to say, that there's certain ways to ask questions that are likely to yield an answer. We're not very good at seeming human-like, so we've never been able to pass for that you might be talking to a human. Computation is always very stilted in comparison to natural language. And if it isn't a structured data with a well-defined set of rules, then computation has nothing to say. You have to figure out what the rules are before you can apply computation, whereas LLMs do a reasonable job really with anything. Not necessarily right, but something reasonable. And most importantly, which I'll get to later, is they can deal with unstructured data, which has always been the kind of hard work of data science, is to structure data before you can do computation on it. And LLM's ability to deal with that unstructured data is really powerful. So I'm not going to go through this in great detail, but let's just look at a couple of these. Here was one that I did as I think this was GPT 3.5. You have to go slightly bigger with the examples before they fail in the latest models, but still, it's innately the same fundamental problems. Here's it failing on arithmetic. It gives an answer, but it's not the right answer. And in fact, if you count the digits, it's about 6 or 12 digits too long, so it's not even the right order of magnitude. And when you get to things like calculus, then here's GPT giving an answer to a integral problem, and it's a little bit like there's an old musical joke here of somebody playing the piano badly, and the guy says, "You're playing all the wrong notes." And he says, "No, I'm playing all the right notes, just not necessarily in the right order." And that's really what ChatGPT did with this integral, is that it knows its answer is likely to have words like sine in it and cos in it, and in fact some things like a quarter have popped out from experience, but actually the answer is just fundamentally different because it doesn't understand that the structure of these things is important. Now, the thing that most people focus on is the reliability, and there's a really important thing to understand about the reliability, is that the design goal of large language models in their training, they are rewarded for being plausible. Their job is to sound like the kind of text that you would read. Now, as a side effect, they are often correct when you ask them a question, because the right answer is, of course, very plausible, but it's not a requirement of a plausible answer. So very often, particularly when you get into detail, things like numbers that have been kind of compressed out of a way in packing all of this sort of knowledge into a fairly small model, you end up with it trying to extrapolate the kinds of words that you would see. So here's my go-to example I've shown for a while, which is provide data on livestock populations in Turkey, and you get this beautiful essay, very nicely written, very fluent, and it's come up with some numbers, and I've highlighted one of them which is wrong here, but actually all of them are wrong. But actually, what's really important about this example isn't just that it's failed to get the correct answer, but it knows the kind of thing to say to convince you. And so it's done what any good essay writer should do, is it's given a citation and it says, as of 2020, here's some figures from Turkey based on data from Turkstat. Now, sometimes it completely makes up citations. When I ask it to talk about me, it often invents books I've written. But in this case, Turkstat's a real thing. But if you'd spend the time to go and find the pages on Turkstat that describe this particular piece of data, and you find the numbers not right. So it's not just that it's wrong, but it's trying to convince you, like that kind of loudmouth guy in the pub who wants everyone to think he's clever, is trying to convince you that it's right with smooth talking, even though it doesn't necessarily know the answers. Now, again, I'm going to skip over some of these things, but one thing that's been very useful for us is this fluency of being able to handle a wide range of inputs. So this is an important step in how we've helped to integrate some of our technology stack, is that you can ask LLMs to rephrase things into simpler forms. So that problem of how do you take a totally open-ended question and map it to something that, say, Wolfram Alpha can cope with, is now solved by the LLM. And I'm just going to add a comment here for a breather, just in case I get a dropout. There seems to be a thunderstorm here in the UK where I'm broadcasting from, so there's always a possibility I may have a power outage and we end early, just to warn you.
Thanks, John. Would it be possible to increase the magnification just a little bit?
Yeah, sorry, it's some of these screenshots too small, like that.
Yeah, that's
Okay.
fine.
Um, and one of the ones I think is very important is this ability to do unstructured data. So I've got a little simple example here I provided to GPT, which was to give it the sentence: two basset hounds walking down the street when they saw a Persian cat talking to a Labrador, and ask how many dogs are mentioned in the following text, return only the final number. The fact that it can get 3 out of that is a really powerful piece of data extraction, that we've got context that I haven't mentioned dogs once, but it knows that basset hounds and Labradors are dogs. It knows that a Persian cat isn't. It knows that it can throw away the superfluous information about the fact they're walking down the street, and we can just reach into that sentence and pull out a number. And this is a key part of what we want to pull together. So we got this computational world, this language world. Wolfram GPT that you've been hearing about, of course, its job is to package that up as the simplest way of putting those two worlds together. So here's my livestock query again, and you've seen this if you were on the previous webinars, that in the Wolfram GPT, it can go off and say, cool, it rephrases the question, probably doesn't need it too much in this case, but it rephrases it into a way that Wolfram Alpha can consume, gets the facts, and then writes its fluent essay using factual information that it retrieved from behind this used Wolfram grey box, and its other mode being to write code. So when I say make a bar chart, it synthesizes the programming language code in Wolfram language to make a bar chart from that data, executes it on the Wolfram cloud, makes a picture, feeds that back into its essay. But that's really the kind of just the start point, the idea that you can just make Wolfram code and Wolfram Alpha available to ChatGPT. You're still in the world of very free-form chat interactions. And there's other ways round for this, both in terms of purpose and control. So in the Wolfram GPT, the large language model is in control. When I asked this question, it decided that it had to use Wolfram. Now, we've given it some prompting to help it understand when it should, but this is GPT in charge, calling on it, help from the Wolfram world. We can also do things the other way around. I'm jumping into Wolfram language now here. And again, I know there's been a previous webinar on these things in action, where in this case, I've got a LLM function where I've written a program in English rather than code. And I'm saying, write a blah summary of blah share price yesterday, given the following facts, blah. And then I'm feeding that function with some information that's computational. But the point of this example is that it's the other way around. What we have is computation in charge. We're getting making the choice on the style of the story. Okay, in this case randomly, but in a proper example, it would do some analysis. We are generating database retrieved data to get, in this case, let's just run this here to see what that would give. That will hopefully give us the open, high, low, close, and volume prices of Microsoft as of 15 minutes ago. And then it's using that to inject into the LLM. So all the facts are already provided. The LLM's not got no choice. The facts arrived along with the request. And it has a tendency to use the facts when it's given them. So we're saying, using the following facts, write some nice words. And that's the computation driving um, and using the LLM as kind of just computational infrastructure. Now, where it starts to get more interesting, of course, is if you start thinking about your own problems. And so rather than having this generic plugin, what we want to be able to do is to have this combination of general large language model, but very specific computations, the kinds of things that you actually care about. And again, this is why we've been building these ideas of LLM tools within the language, where I can say, in this case, write a short paragraph about two cities, but provide a tool that is giving a custom calculation to the LLM to use on demand. In this case, one that happens to know how to look up the populations of cities within the Wolfram language. So we're just saying, take the city that's mentioned and find its population. We've interpreted that city as a city, and there's a little bit of explanation about what the tool is and what it's called. And now these words from here down to here came out of the LLM, but at this point it knew to go and find that specific tool value and then continue writing, and then call the tool again and continue writing. Now here, this is the kind of thing that Wolfram Alpha would have done, that if I use the Wolfram GPT, it would probably do exactly the same kind of thing. I've tailored it slightly by pointing it towards populations rather than general information about the city. It might, with Wolfram Alpha, it might tell me all kinds of things about them, like crime rates or whatever. But once you've got this kind of ability, then you can start adding private models. So if you've got an engineering system model of how your latest car will behave, you can now make that a tool available to the LLM. So you can start having conversations about what would happen if the right wheel nut failed when you're doing 180 miles an hour around a corner, and it can appropriately set up, it can map that to a query, to a computational model, to run the model, to produce some answer that you can then interpret back in a conversational setup. Take a little bit more than this one-liner, but it's the same basic principle. Now, the same is true of being able to things that reach into data. So once you're in the computational world, you can do anything that computation can do. And of course, the computational infrastructure has been building for a long time for doing all kinds of things deterministically with code or calculations. So it's the same kind of principle to say, okay, I'm going to write a tool that says, write an apology email to this person from Mike Smith for not attending an event, but I've given it a tool here. So the evaluator here is to say use GPT-4, but I'm going to give it a particular tool that says I can take find the person's correct email from name from their email. And what that bit of code does is it does an SQL database lookup. So it's going to select username from users where email equals the incoming email and pull that value out. So now we get this email that it writes all LLM generated, but the fact that it knew that my name was John came from that database. So this kind of tool is going to allow things like customer service databases to be able to compose response emails automatically to people with access to the customer information, simply by using the tool as a bridge to computation, which is a bridge to the database. And likewise with remote APIs. Let's not do that one unless people are interested later. Now, one of the things that I said early on that I thought was important was unstructured data. So most people are fixated with the LLMs on chat because it's never been possible before to pass the Turing test and have actual conversation with a computer that feels real and is on topic and stays on topic. But it's not the only great thing about LLMs. And very underrated is this whole ability to handle unstructured data. And here's my sort of simple go-to example. This is using, again, one of our abstractions on LLMs that you've seen in the last few days, the example function, which is giving it examples of things it might see and what you want to do. So I always liken this to getting some fresh intern in, and then on their first day, you sit them down at the desk and say, okay, here's what you're going to see. You're going to see text like this. John's a 52-year-old male who's 6 foot tall, and I want you to rewrite that in a Wolfram language key value association. Name goes to John, age goes to, and I want you to use quantity to explain that this is in units of years, and likewise height. And I'm going to give another example where I haven't mentioned all the information, and show it that in that case I want to see the word missing. And another example where two people are mentioned, and this time I want to see that there is a list of two associations, one for each person. Once you've got that, we can now give it this unseen data, and this in-context learning, this sort of example-driven learning, is enough in even in very small number of examples like this, because of this innate knowledge that comes with the LLM. It sort of gets it from the examples. And I've given it this sentence here that's completely unrelated to the previous ones, but it knows enough from the context of the examples and what it knows about English in general to turn that into the data set that I wanted. And here we've got the key value data sets in name, age, and so it's a bit small, and height. Everything's in the correct Wolfram units. When I say find the shortest person and convert the height to miles, that just works. And we've bridged that gap from messy data to structured data. Once we're in the structured data world, all of those 35 years of data science that we've been building becomes available to you. You can do all of the kind of correlations and projections that you want from it. You can find trends, you can build machine learning models from the raw data. But the LLM is providing this bridge from the mess to the order. And that's a really powerful thing. And this example function is really turns out to be a really general and flexible paradigm. Yes, I'll do that one. So this is one that I got involved in with we've got a project going on with that has just started actually with a medical voice transcription company. So they're in the business of chatbots where you can phone up and talk about medical conditions. But one of the challenges they faced when we first started talking to them was transcription errors, because you've got these voice to text encoders, but they are trained on normal conversation, and medical conversations have low frequency words in, and they were getting mistranscribed. So this is exactly the same concept as before. It's an example driven function. I've given a bit of explanation what its purpose is, first of all, that is to fix transcription errors. And there's actually only two examples in this training set here. Topic heart, you have a tastemaker. That is a mistranscription of you have a pacemaker. And then I've got another one in the topic parts. So Asian populations could be heart disease, atrial fibrillation. So they sort of phonetically both of them sound quite similar. But I think it's kind of remarkable that after just those two examples and a bit of explanation, you can start giving it things, not even in the topic of hearts, we're now in the topic of eyes. I have cats and a glaucoma, one of the failures that they gave me as an example. And the LLM can correctly fix that as I have cataracts and glaucoma. So again, we're going from not just unstructured now, but inaccurate unstructured data, and we're able to transcribe that into structured and or factual data. And another medical context I had here of just trying to validate data. This is one that relies a little bit heavily on the LLM's knowledge. So if I was doing this in reality, I would want to call this via a tool that had a computational lookup for the topics of drugs, and then use the LLM to match them. But in this case, I've just relied on the LLM's knowledge to say that we're trying to just spot the drug in a sentence and whether it's the correct application. Patient had headache, I prescribed aspirin. Drug is aspirin, that was the correct use. He's taking warfarin for his blurred vision. Drug is warfarin, that's not the correct use of warfarin. It's got nothing to do with vision. And again, from those examples, I can now start validating text by saying, tell me what drug was mentioned here and is it correctly in the correct context. And loperamide is not an appropriate drug for a broken leg. It's an appropriate drug for an upset stomach. Now, as I say, you have to be careful with, particularly with medical context, that in reality, this is thrown together as a demo of LLM example function. But really what you want to be able to do is to say, identify the drug, call an external tool and say, what are the correct uses of this drug? Identify the injury or the medical condition from the sentence, and then use an LLM to say, does this medical condition sound like one of these typical uses of the drug? And that level of matching is probably more reliable than never ask an LLM for its knowledge if things matter. Is my short piece of wisdom on that. Now, another thing in the kind of data science side is just mapping things. It just used to be really hard work, where you had to build lots of dictionaries of things. And still in the medical context here, I've written this very simple LLM function that converts a drug name to the purpose of the drug. Again, it would be better with some examples, but even with this one sentence description, be able to take a database of values like aspirin, warfarin, heparin, and say, make a bar chart of the counts of the purposes of those. The fact that one of them was an analgesic and two anticoagulants didn't require me to build a big dictionary of all of the different things that I might see and how they map. Let's look at a different context now. Now, another thing that's useful, is important, is I'll show better examples of this in a minute, but within the world of assessment now, suddenly open-ended questions have become reasonable things to have, where previously only multiple choice or human marking managed. So we can have questions like, what is an omelette? And I can say things like a food made out of eggs. And this is probably the first actual calculation I've done here. So it's probably going to take a few seconds to initialize, but okay, well, that's unfortunate. I'm not sure whether... no, I don't think I did anything very strange with that. Okay, that's a LLMs sometimes let you down. Let me try that one more time. See if it gets it right the next time. Okay, that time it got the right thing. I'm not quite sure why it got it wrong the previous time. And if I said presumably something very different, like a large machine, it should give me a cross to say that was the wrong answer. There we go. So I'm not sure whether it just failed to initialize the first time. I should look at that. But all kinds of interesting things, and I'll show you some richer examples in a minute, become possible. Now, another thing that you will have seen over the last few days, but it's a really important part of the bridge, is that because these are language models, they form a great layer for translation. And that can be things like, I can do actual translation. I can say translate to French. Hello, how are you? And it does a pretty good job across all kinds of languages of being able to translate. But actually, more important in our world is the translation between the computational world and the language world. So being able to translate things into Wolfram language code, or to translate other programming languages or data structures from one data structure to another, it turns out all essentially the same problem. So, for example, translate this JSON to XML is exactly the same problem. Now I've set myself up for having to remember how to type JSON. A goes to A colon B, is that the notation? I guess I got that good enough, or it's figured out what I meant, even if I didn't write correctly valid JSON there. Those kinds of translations are all very linguistic. They're about syntax and structure and order and vocabulary, and so the whole machinery is very good at making code on the fly. And actually, it's particularly useful for Wolfram language for a couple of reasons. One is that we have a very natural language-like language. We have high-level words that do a lot. And so you can actually generate more powerful programs very often in fewer words, which means the LLM is capable of actually writing really quite powerful Wolfram language code before it gets to the point it gets confused. And on the negatives of our language, the language is very large, which makes it hard to learn, but the LLM doesn't have any problem with consuming large amounts of information. So it can be aware of the 6,000 commands in the Wolfram language in a way that as a casual user, you might not know many of them. And of course, it's important because Wolfram language isn't one of the top 10 languages in the world. Having bringing people in with the skills to be able to use it is a challenge, and one of the first things people have to do is to learn the Wolfram language when they start using us. They don't come pre-trained in college very often as their primary language. But now that doesn't matter because you can synthesize code straight through from the LLM. And of course, you will have seen in the last few days the chat notebook, which is our sort of primary mechanism for doing that. So let's get a chat notebook up here. And the idea is that I can just now talk in English, but have that translated into the code. So I can say, plot the differences between the first 1,000 prime numbers. And I realized that I probably want to do something better than that. Plot the moving average with a window of 200, probably what I wanted, because I probably wanted a smooth line. So there's the first 2,000 prime numbers, and here comes the code to make the moving average. And I haven't had to know anything. Now, obviously, that there's a limit to how far that can go before that. I needed to have copied down both bits of code. It assumed I'd run the first piece of code. There we go. So now I've got the code I need to be able to modify and tweak that and build it into other things. So that's a big learning barrier to overcome. But the chat notebook, we needed this. Our obvious first step was this: can we use LLMs to make it easier to use Wolfram language? And very quickly that led us into the conversation of, well, is this the way you want it? Lots of explanation, some code, more explanation. Maybe you're actually, you're not learning, you just want help. Somebody like me, I don't need the code explaining to me, but sometimes I can't quite put my head around quite what I'm going to do, and I just want to say do this and save myself the brain power. I don't want all this explanation. And that led us into the world of having, well, maybe there are different personas that we want. The code assistant is the beginner version that gives you lots of explanation. Code writer just writes the code and doesn't give you any verbiage around it. Gives you a much more compact thing, and for somebody like me is more the way I would use it. But this idea of personas itself is a important idea, because you can extend that with the plugins that we've talked about. Here I've got the Wolfram Language Evaluator plugin is one of the kind of built-in plugins for these personas, because of course we need that. But we want to be able to provide plugins for your custom knowledge as well. Just as I've shown in code, we want that to be available within the chat notebook. So in fact, this plugin here, this particular one is, as I said, the code interpreter that says here's what the code was and what came back. That could be any one of the plugins that the language that I showed earlier set up. So the LLM tool can be anything you want, and that then becomes available in the chat notebook. So now that gives you an instant interface to custom computational knowledge in an environment, together with the kind of persona management of being able to create the style of what you want. So let's look at a couple of actual sort of applied examples of those things. First of all, let's just look at I'm going to do a new chat notebook again. Actually, I've still got one open. Let's go back to that. No, let's do a new one. track-driven notebook this time. And I'm going to switch into a custom persona that I've made.
John, magnification for the
Thank you. Thank you. So this is a lesson planner persona. So here, there's no plugin actually. This one I've just created a persona for the purpose of being a teacher who has to make a lesson plan. And let's just say hello to it to start off with. And you can see here that it's a topic specific thing. So it knows that its purpose here is to make a lesson plan for a specific topic. So I'll say, we'll do Henry VIII. That's not how you do eighth, is it? There we go, Henry VIII. And it's got certain engineering around it that tells it that there's things that it needs to know to be able to do this. Like, I can't just come up with a lesson plan without knowing how old your kids are. And are there any specific props you want to use or things do you want to base the lesson around? I'm not gonna tell you what the topic is. I'm just gonna say 5-year-olds use a hat. And we'll see what it wants to teach me about Henry VIII. So now it thinks it's got enough. It knows what a lesson plan should look like because I've built that in with the engineering of this persona. And you can see it's coming up with a lesson plan. What is its lesson plan? Okay, it's know who Henry VIII was and recognize Henry VIII's famous hat. I think it means a crown here, but we'll see. Well, this is a bit of a spurious one. It normally does slightly better than this. Usually goes off on something about the wives of Henry VIII, and but then I didn't say for 5-year-olds, so it's got a game which is passing the hat round a circle. Okay, well, I mean, it's a lesson plan for Henry VIII. It's got timings, it's got purpose, and what you'll learn. That's all part of the engineering of it. Now, sometimes if you want to do something that's kind of more focused, then one of the things you need to do is lock down that it won't talk about other things, but also to give it knowledge here. So let's close this out and let's switch to a new persona. And I'm going to switch now to Retail Assistant, another demo persona that I wrote. And the idea of this one is that it's customer service assistant for a shop. I've been shopping and can I return? I bought some smart chinos yesterday. I changed my mind. Now, this persona is got to have knowledge to be able. It's not just using its kind of LLM knowledge of Henry VIII or whatever. This one needs to know some things about the purchase to be able to answer my question. So it knows it needs to ask who I am. So I'm going to say I'm John McLoone. And at this point, we are reaching into a database to get purchase information. So it found that when I bought them, good news that they're eligible for return. In this particular example, I have a limit on the return period. And let's say how much refund do I get? It needs to know what I purchased those things for. And there's other tools available to this persona as well. So I could say, what could I buy with that? And now it's going to take that £35 and say, suggest a product is one of its backend tools. Oh, and let's ask it again. It's supposed to have a default value for that because I didn't specify product type. What clothes could I buy with that? I will have to fix that example. So actually this inadvertently has shown what can also be sometimes interesting behavior for the LLMs is that it's made a bad call for the endpoint. It can only accept the words clothes, home, gifts, and any. And I typed lowercase clothes. For some reason, my prompt engineering failed and it didn't translate that correctly. But then because it got the error message, the LLM is able to figure out what it did wrong and it calls the tool a second time. And this time it's called it correctly, or it's actually switched to product type any. And then it's got back some data from the endpoint, which is then used to fashion its answer. Now, when you start sort of opening your mind to the idea of kind of purpose in the prompt engineering together with tools for doing things, then all kinds of kind of different tools become available to you. So let's, I'm just going to save this to my desktop here so it knows a directory that I'm working in. And let's switch to another persona now, and we will do document reader. This is something that's been a kind of popular application for LLMs, is to be able to reach into knowledge bases and get useful information. So somewhere on my desktop, I've got a press release for some bank, and I can speak to my persona and say, summarize press, let's get a bit of clue here, press release, annual, something. I can't actually read it on my desktop, but it's hopefully will do a nearest to figure out what I'm talking about in 30 words. So when you have a lot of knowledge tied up in documents, the ability to have a tool that can go out and read this PDF file, convert it into text, pass that back to the LLM, and have it then be able to read that and summarize it. So this was a press release for Rabobank posting profits, but I don't have to read the whole document. I can get that summary, or I can start reaching in and saying, what new initiatives were there? Something I know the document speaks about. I don't have to trawl through the document to find the bit that tells me that's something the LLM is very good at, of reaching into the document and letting me interact with the knowledge in there. So here's the 5 initiatives that the press release announces going on within that. And we could do more subtle things like did high interest rates hurt profits? According to the document, they in fact drove profits for the bank in this particular period. So this, together with the kind of the search layer that finds the right document, suddenly makes it possible to do research quite quickly. But this whole kind of reaching to the document and the finding the document, that's just another kind of computation, another thing that that the kind of tool mechanism can bridge the gap between the computational world and the LLM world. How are we doing on time? We are running out of time gradually. So let me show you another educational example here. This one not on the assessment side, but on the tutoring side. We've got some interesting directions coming, but this is a particular thing I've been involved in on our computer-based maths project. So we have a project to try and rethink what maths education should look like, or computational thinking should look like. If you assume that computers are there to do the computing. And we've built all kinds of interesting materials with some projects. One of the barriers we've all known all along is that the teachers aren't trained to do that. So we've got lots of teaching notes. But we asked ourselves the question, well, what if we didn't need a teacher? What if you had an AI tutor? How would you help the AI tutor to figure out what to do? Well, that's the same thing as the teacher notes. So when you've got lots of teacher notes, that's an instruction to program a teacher in how to give a course, how to answer the student question, how to direct them. That's the same programming you need for an LLM to teach it to be a tutor. So in this particular example, we're down in the project section of one of the computer-based math modules. It's all about hypothesis testing, and it's about, are referees biased? Do you get more red cards when you're away than when you're at home? So in our tutor here, at any one point, you can chat to the AI assistant, and the AI assistant knows the context of where you are in the materials by where you're talking to it. So the fact that we are here in the define a question section for materials, it knows it's supposed to help me to define a question. So it's prompting me here with, be a bit more precise here. What are you looking for here? Can you give me a bit more detail? And eventually I'm going to say something precise enough that it thinks that I've kind of formalized what I'm trying to achieve. And And then when we go on to, I don't think it's still asking a bit more on this. Oh, it's still asking for further refinement. But at some point it moves me on to the abstraction step. Oh, actually, I got bored here and said, okay, I'm going to move on anyway. So actually, even at its passing gesture here, it said, okay, so here's what I think you're trying to say. And in the final bit, we go on to the next step, which is abstracting. And I can ask it for things like, well, is there any data you can give me? And here it now knows we're in a different part of it. It knows the context of what data is available. So at any one point, it knows what I'm supposed to know by this point, what I'm supposed to be doing right now, what its parameters of what computer-based maths as a philosophy looks like. And so all of its answers are trying to keep me on that storyline. And that's kind of a slightly different way of thinking from sort of classical prompt engineering, where you have some prompts that say you're this such and such a persona, go chat. Here we're changing the prompt at each point in the document. So when I click somewhere else and ask a question, all of the prompt engineering is different for that point in the document, so that the AI knows what I'm supposed to be doing right now. Okay, let's maybe wrap up with one last example, and this is really putting together the ideas of along the lines of the customer service assistant, but in a kind of open-ended assistant kind of way. So rather than being just a kind of gateway between you and some action, we want something that's totally open-ended. So much more like the original idea of a notebook where you can go anywhere. And I've got a pre-record on this one. Give me a few seconds to open it. Okay, here we go. So in this example, we are working for a food company, and we're a scientist whose job is to decarbonize the food lineup. And so what we need to do is to pick a product and figure out how we're going to make it better. So that's a pretty open-ended task. We need to reduce the carbon footprint of, in this case, our peanut butter cup recipe. So where do I start? Well, I ask it, what are the ingredients of the peanut butter cup? This requires reaching into the ingredients database, so that's a private local database. Then there's IDs to come back, so it has to call an ingredients details database to find out what the common names of those things are. And here's our kind of human readable ingredients for this peanut butter cup. Now, my next question is, well, what are their CO2 emissions? What am I trying to, where can I improve this? So now we're going to another database, but because it knows the context, it's passing in each of those ingredients as part of the query into the CO2 database and saying, well, here's the manufacturing cost of each of those ingredients in terms of CO2. But of course, I don't care about them in the abstract. I care about the proportions in the peanut butter cup. So now we're going to put together the two pieces of information. So that requires a little bit of code to multiply the proportions of the ingredients by their CO2 contributions, and then make a pie chart out of that so I can understand it. And whenever we've got these gray blobs in the chat notebook, we can click on them and see inside and see what was the actual conversation, check that the code was correct for audit purposes, or because we kind of want to understand, not be fooled by some error. So now we know which is the most polluting. How can we get rid of it? So it looks up what's the purpose of that ingredient, and it says that's it's a preservative, and here's 4 alternative preservatives that we could use. And so I now ask it which preservative would be the best one for if I'm just focused on CO2 emissions, and it's now looking their costs up. So it's recommending sodium benzoate as the lowest CO2 emission in those terms. But it's not just in isolation. I have to think about other factors. So here I ask it now, what's the shelf life if we used that? And there's now a computational model being called that has in it a computed shelf life that says this thing should last 7.08 months, according to the model that has been provided for shelf lives based on ingredients. Now, so far, I've been trying to make life easy for myself, but you also want to have the ability to have things like this be just there for deep dive. So if I want to jump into the knowledge database and say, tell me everything you know about the two molecules in question, then I can get kind of the knowledge database from the Wolfram knowledge base on each of those two things. And of course, one of the things we need to do with these kinds of personas is building the guide rails. So as a test here, I said, what if I replace it with cyanide? It warns me, but oddly it then goes on and gives me the information on cyanide, having told me I really shouldn't use it, and then it wraps up by saying you really shouldn't use it. So that example should probably be tightened up a bit further, just to not even go into that conversation. If you're using the word cyanide in context with food, it should probably just shut you down. But here it's just told you don't use it. By the way, this is the chemical properties of cyanide, in case you're interested. So all of those things, in the end, all of those examples, they're all doing exactly the same things behind the scene. I'm just going to open one of them up here. Let's look at document reader. I don't know if it's the best one to look at. This is quite a simple bit of code that I put together. I've given it a name. I've given it some prompt engineering that says what its job is to do. Just help it understand what it's supposed to be doing, which is reading a document and answering questions, telling it not to speculate, help to try and reduce its willingness just to guess at what the document would have wanted to say if it had the chance. And there's an icon, and at some point there's a tool. So my tool here is actually very badly written, but it finds the nearest file name, and then depending on the document type, it either tears apart a notebook, which probably should have used notebook import, or it does an import on the file if it's a PDF, or just reads the file if it's plain text. So it branches a few ways according to which thing it is to always give me plain text. If I can't figure it out, it says I can't read it. And that's all there is needed to make that document reader. To find the thing, other than doing nearest file, you need to put some kind of second tool on that is effectively an indexing tool. But that would simply be another tool to say, find a document and read it. So all of these things are, in the end, just two components. There are the LLM component and the computational component. And all of them, I've got a somewhat complicated diagram of the various points to connect, but all of them essentially are trying to follow the idea that like any good human, we've got a kind of creative, fluent, poetic side of our brain, and we've got a logical side. Wolfram Language and computation have been doing the logical side. The LLMs now fill in that sort of creative and poetic side, but the two together is what's needed to really solve interesting problems and get the kind of the most power out of the computer.